Hi geographers, and welcome to the latest episode of the CVA Geography YouTube channel. In today's lesson we are going to be looking at what are tropical storms. So what I want you to do first is just write the title down, pause the video here to completely do now. Thank you. Right, so let's go through the answers. We've got number 1, we've got is high unemployment, number 2 is 9,000, number 3 is increased, number 4 is a natural event that becomes a natural hazard when it affects people, number 5 is when cold air sinks, it creates an area of high pressure, number 6, the cell between the equator and the tropics is called the Hadley cell, and number 7, a social challenge in Lagos is 60% of people do not have access to clean water. If you did stretch it, you'd say this means people are more likely to contract cholera, which means more people are going to be sick or die, therefore there's less economically active. So let's crack on. What we're looking at today is what tropical storms are, where they're found, and then an understanding of how climate change can impact tropical storms in the future. What I'd like you to do now is just to pause the video and just to write down the 3 key words. So low pressure air, the Coriolis effect, which refers to the spinning of the earth and how air moves over it, and storm surge. Perfect, let's crack on. So, first things first, what is a tropical storm? If you look at figure 2, you can see a picture of a hurricane, a tropical storm travelling over the Caribbean. It's got distinct features. It's got a eye at the centre, which is an area of high pressure, which basically has no rainfall, and around the eye is an eye wall, which is where you can see the really thick cloud, which is an area of low pressure, and that's where we get the strongest wind and the strongest rain. So figure 3 also shows you the damage these tropical storms can cause. They bring with them strong winds, storm surges and heavy rainfall. And our tropical storms are severe low pressure weather systems that cause extreme weather, and they form over the sea and have devastating impacts on islands and coastal areas when they reach land. So where on earth do we find these tropical storms? If we look at this figure here, we can clearly see that tropical storms form around the tropics. They form between 5 and 30 degrees north and south of the equator. So they mainly occur in tropics, like I said, and they've got different names as well for the oceans that they form in. We have cyclones in the Indian Ocean, typhoons in Southeast Asia, and hurricanes in North America. All of these cyclones, typhoons, and hurricanes are the same thing, they're all just tropical storms. So, tropical storms formed between 5 and 30 degrees north and south of the equator. That is so crucial, I suggest you write that down. It's also worth writing down that the tropical storms form over sea temperature, which is 27 degrees Celsius or higher, because the moisture evaporates rapidly. There is rising air, which is called low pressure, and there's also a deep ocean area of over 60 meters, which provides the evaporated moisture that energy to keep rising to form the storms. So, if we look at this in terms of an exam question, we've got here, using figure 4, describe the global distribution of tropical storms. What you need to do to succeed is you need to give a sentence, a general pattern, where on earth do tropical storms happen? You need to 2, locate an area with many tropical storms in a year. 3, locate an area with few tropical storms in a year. Use numbers from the key and use place names. There's a stretcher task there for you as well, so if you could pause the task here and have a go at just describing the global distribution, so what is the global spread of tropical storms forming using that success criteria. Brilliant. So, what you should have got is tropical storms occur on or around the Tropic of Cancer or Capricorn. In the Pacific Ocean and Southeast Asia there are many, with 3 per year in places. Fewer tropical storms occur in the north of the Indian Ocean around India. Here there are fewer than 1 tropical storms a year. More tropical storms in the northern hemisphere, so any variation of that, you need 3 of them to get 3 marks. So, tropical storms, how do they move? So, tropical storms spin because of the Coriolis effect, and that creates these rotating storms. In the northern hemisphere, they travel and they spin in a clockwise direction, whereas in the southern hemisphere, they travel and spin in an anti-clockwise direction. As tropical storms move over the ocean, The energy from the warm water evaporating strengthens the storm and the wind speed increases. So the longer the storm's over the water, the stronger it gets. Tropical storms lose energy when they travel over land. This is because the energy source of the warm water has been cut off. What I want us to, right guys, so what I want you to do now is have a look at this map, figure 8, showing a path taken by Typhoon Haiyan. Path just means the route, the way it's gone. And it says here, describe the path taken by Typhoon Haiyan, 3 marks. The path is indicated on the map as the red dotted line. You can see it starts here and travels this way. And you've got a compass there as well to help you. So, to succeed in this, you need to, 1, identify where the typhoon starts and where it ends. You need a sentence then to identify the places the typhoon passes through, and try to use compass directions and place names. There's a challenge task as well, and what I'd like to do is just pause the video here and have a go at answering that question. Describe the path taken by Typhoon Haiyan. Brilliant. So, well done on that. Here's the answer, what you should have got. Typhoon starts to the east of the Philippines in the Pacific Ocean, it travels west through the Philippines and across the South China Sea until it reaches in Vietnam. Alternatively, you could have said here the direction changes northwesterly and then northerly as it moves through Laos and Vietnam and finally ends in the south of China, by which point the direction has curved to now travel towards the northeast. Brilliant. So, what I want you to do now is get another piece of paper, or turn the piece of paper over you're using and split your page into 6. Okay, we're only going to draw 5 pictures, but into 6 makes it unique. And what we're going to do is I'm going to talk through how these tropical storms form. I want you to draw the picture and annotate beneath or around the picture what exactly is happening. Okay, so for these tropical storms to form, in step 1, you're going to draw the sun warming the ocean. Okay, you're going to write 27 degrees on the ocean and 60 meters deep. So the first step for these tropical storms to form is the sun heats the ocean to 27 degrees. This causes rapid evaporation, and the ocean must be at least 60 meters deep, or otherwise there's not enough power for the storm. So it's really key that you get the picture down, the fact the ocean is 27 degrees, it's 60 meters deep, and it causes rapid evaporation. Then we go on to picture 2. What we need to draw in picture 2 is the sea, and draw the arrows to show the evaporation with a nice thick cloud above it. So condensation occurs quickly, leading to large amounts of clouds forming. It's now called a tropical depression. And then we go on to step 3. Remember, you can pause it if you want for each picture. Step 3, we've got our clouds, but we've now got a gap between the clouds and it's starting to rotate the storm. And this is called the eye of the storm. So due to the Earth's rotation, this cloud mass starts to spin. An eye is formed in the centre, and here air is sinking and the wind speed drops. So if you want to also draw in a downward arrow in the ice, air is sinking, make sure you get down the notes that the wind speed drops and it's calmer there. Then we have picture 4, and where we've got this air sinking, we've then got air being pulled into the storm as well beneath it. So we've got an area of low pressure where the air rises, and due to the rise in air, a low pressure forms below the storm. Air rushes into the low pressure, creating high winds of over 74 miles per hour. And this now causes a tropical storm. So beneath the storm we have that low pressure, and that low pressure means the wind is drawn into the low pressure, which when it hits 74 miles per hour forms a tropical storm. And in addition to that, so please, like I said, pause the video and get that drawing down. And then we've got our final step, step 5. In step 5, we can now see there's that low pressure beneath the tropical storm. We have the sea rising up, and that's called storm surge. So the low pressure results in the ocean being uplifted from a storm surge, a large wave. And this can rise the sea level up to 8 meters, causing lots of flooding in coastal areas. So then pause it there, make sure you get it down. Okay. What let's do is just double check my version and your version, make sure you've got the 5 steps of the tropical storm. So the ocean is 27 degrees Celsius and 60 meters deep, and there's rapid evaporation. Step 2, this rapid condensation forms large clouds, and that's called a tropical depression. Step 3, the clouds start to spin and an eye forms in the centre where we've got air sinking. Step 4, low pressure forms below the storm. You get high wind speeds as the air is drawn in, and when it hits 74 miles per hour, a tropical storm forms. And then number 5, low pressure causes the uplift of the ocean, and this is a storm surge. Brilliant. So what I want you to do now to practice that you can explain these 5 steps, so I want you to put it into a piece of writing for me, and I want you to explain the formation of tropical storms. As a success criteria, it says use all the key terms from the boxes and make sure it's in the correct order. So I'll show you a model of what success looks like. Well, what an answer could look like, and there might be some good and bad aspects to it. So, tropical storms form between 5 and 30 degrees north and south of the equator. They form above warm oceans that are 27 degrees. Brilliant. Mist and term, I could say rapid evaporation. The heat from the warm ocean creates rapid evaporation. This warm air rising condenses quickly and creates rain clouds. The Coriolis effect causes the wind to spin around the centre of the storm, which is a calm area of low wind speeds in the centre of the storm. The storm is now called a tropical storm, and beneath the storm there is uplift of the ocean, which is known as storm surge. So you can see I'm missing a few words. Rather than calling it the centre of the storm, I've called it the centre of the storm rather than calling it the eye. I haven't used the word low pressure or tropical storm. Okay. So what we need to do is, using your diagram, I'd like you to pause the video here and have a go at trying to answer that question for me. Brilliant, really, really well done there, guys. You should have had along the lines of tropical storms form over water that's 27 degrees Celsius and 60 metres deep. This causes rapid evaporation of moisture, which is then condensed in the sky to form large clouds. Due to the Coriolis effect, the tropical storm spins around an eye. Beneath the tropical storm there is low pressure, so air is drawn in here, creating high wind speeds, which creates a tropical storm as speeds hit 74 miles per hour. Due to the low pressure, there is an uplift of the sea, which can create a storm surge beneath the storm. So as to tropical storms, how they form, what we need to think about now is how can climate change affect tropical storms. So tropical storms are seasonal. They mainly happen at the end of summer because that is when the sea temperature is warmest, and it has to be 27 degrees. Climate change is increasing the global average temperature, and this in turn is changing the distribution to where storms happen, how often they happen, the frequency and intensity, how strong as well. So, distribution, as the temperatures of Earth increase and more sea temperatures are above 27 degrees, what we're going to start to see is tropical storms happen further north and further south from 30 degrees north and south of the equator. Okay. Frequency, what we're going to start to see as a warmer climate means the oceans will stay warmer for longer. This means that the period where the storms can form is now longer, so therefore we should be seeing tropical storms happening more and more often. Okay, so sea's warmer for longer, therefore tropical storms happen more frequently. And then we've got intensity. So the higher the sea surface temperature, that means that more moisture is evaporating. So more clouds form, so the tropical storms are getting stronger. So what we can see here in figure 8 is the tropical storms after the year 2005 are causing more damage. So the warmer the sea means more moisture is evaporated, storms are becoming stronger, and that means that there's more damage to be caused. So we can see climate change nice and quickly. What it basically means is if the sea is warmer, tropical storms happen further north and south of the equator. If the sea is warmer, the frequency, the amount of tropical storms, there'll be more of them. And if the sea is warmer, the power, the intensity these storms have, it will have more power. Hopefully that's not too groundbreaking news there for you guys. So what we need to do now is a little bit of a comprehension task, just go over what I've just been through really. So I want you to answer the following questions. Copy and complete the following sentence by choosing the correct term. So we've got sentence there to the copy down, choose the right words. Question 2, 3, 4 and 5, all the answers you need are going to be on the left of the screen. So pause the question, pause the video and just jot down the answers to the questions for them in your notes. Brilliant, well done guys. Awesome, great work. Let's see if you got the answers correct. So did you get number 1, climate change is raising global temperatures. This means the tropical storm frequency will increase, intensity will increase, and distribution will start to be found in more places. Question 2, increased by 0.25 or to 0.5 degrees. Question 3, well, the area never experienced a tropical storm before. Question 4, 16 of the last 24 years have had higher than average storms. And question 5, sea surface temperatures are rising. So what we're going to do is we're going to move on to our blue zone task. And what I want you to do is use everything we've done in today's lesson to try to help you answer these questions. So question 1, describe the track, and that is the path, and the route. The route of Hurricane Irma between 6th of September 2017 and 12th of September 2017. Remember, on the figure 12 there, you can see the names of places. You've got the dates the storm is. So it starts on September 6th, finishes on September 12th, and you've got the compass direction. So you can really go to town. What is the general pattern? Where does it start? Where does it end? Question 2, what happened to the wind speed of Hurricane Irma between the 8th and 12th of September? Question 3, give one reason why the wind speed of a tropical storm may change as it reaches land. And question 4, state a potential impact of climate change on the global distribution of tropical storms. So pause the video here and have a go at answering those questions. Brilliant guys. Let's just go through the answers to see if you've got the same as me. I'll leave them there for you to pause and mark. Really well done today. What I'd like you to do is remember, bring in any work you've done to stick in geography books or email to geography teachers who will be happy to mark it. Please remember to like and subscribe to that the latest Castle Review Academy geography videos. Brilliant.